take a look at this invention called the Perpetual Motion Marble Machine and watch how it works. Have you seen it before? Do you think there's something wrong with what you're seeing? Or do you think it's working like it should? Now take a look under the base of this crafty little invention. Does this make you feel better? Or were you tricked into thinking that this invention really works and that the little steel ball would continue on its loop forever? There's a reason why there's a battery and an electromagnet hidden under this device, because without it, it would be impossible for the steel ball to continue in an everlasting loop, as it would break the first and second law of thermodynamics. It's not a perpetual motion machine, and there's many more examples like it. But is it possible that one day a perpetual motion machine will become a reality? Before we get into the really interesting inventions, it's important to understand the laws a perpetual motion machine would break. A perpetual motion machine, in theory, would be a device that could continue to operate endlessly without any loss of energy, meaning it would operate with 100% or greater efficiency. That said, the first law of thermodynamics, or law conservation of energy, states that energy cannot be created or destroyed, but only transferred to something else. A good example of this is Newton's cradle, which many of you may have seen before. It demonstrates the conservation of momentum and the conservation of energy with the clicking and swinging of steel balls suspended by wire or cord. The continuous swinging and clicking is proof of Newton's conservation of energy law, which states that energy can't be created or destroyed, it simply changes forms. And this is why it's not a perpetual motion machine, because the steel balls lose energy to many things. To the air as friction as they move through it, they also create sound energy when they collide with each other, and they lose energy to heat upon collision, although in this example it's very minuscule. This brings us to the second law of thermodynamics, which states that heat always moves from hotter objects to colder objects, unless of course energy is supplied to reverse the direction of heat flow. Each of these factors cause the steel balls in Newton's cradle to lose energy, and as a result, the steel balls will slow down and eventually stop. For a true perpetual motion machine to exist, the energy would have to stay within the machine, or be a closed device. A device that works entirely without any friction, any external source, and it would have to exist in a vacuum, so there would be no atmospheric pressure on any moving parts. It sounds impossible. That's because it is. However, there are a few inventions out there that we're going to look at that are what many would call the most impressive attempts at building a perpetual motion machine. The Beverly clock is one of those inventions. It sits inside the Department of Physics at the University of Otago in New Zealand. The clock was invented by a man by the name of Arthur Beverly. At the age of 14, Arthur became an apprentice watchmaker, was a very skilled lens maker, and made a set of microscope lenses for the University of Aberdeen. He moved to New Zealand, where he opened his own watchmaking business back in 1858. It's there he began working on his invention, and 6 years after opening his business, he completed work on a wondrous and very different clock. Once his invention was finished, Arthur wound the clock in 1864. This is the only time it was ever wound to start it, and it's been running ever since. To this day, it's one of the longest-running science experiments in the world. So how is it possible that a mechanical clock could run continuously for 158 years without being manually wound? Well, this statement isn't entirely accurate. Although the clock is still running, there have been times when it's stopped. Despite the fact that the clock can, theoretically, run forever without being wound, it does rely on an external power source. No, there are no hidden batteries. The clock actually runs on atmospheric pressure, thanks to an airtight box inside that expands and contracts due to normal temperature changes that occur throughout the day. Changes in temperature create pressure on a diaphragm that lifts a 450-gram weight. When the temperature decreases, the weight falls down and winds the clock. As long as there is a temperature variation of just 6 degrees, which is required to lift the weight just 1 inch, then it will wind the clock. But sometimes this doesn't happen, and the clock just stops. When the temperature does change, the clock will start to work again without being manually wound. Of course, the downside to this is that the clock will have lost time, and will need to be manually set to the correct time again. It's not a true closed system, and therefore not a true perpetual motion machine. It is, however, the closest example of one that we have. Still, the Beverly clock is a brilliant design for the time, and the first ever atmospheric clock in the world. But it runs at less than 100% efficiency, making another reason it's not a perpetual motion machine. It's also worth mentioning that a device like this would not function in the vacuum of space, and it needs gravity to work. If you thought the Beverly clock is an amazing invention, then this next attempt at a perpetual motion machine will surely surprise you. It's called the Oxford Electric Bell, or sometimes referred to as the Clarendon Dry Pile, because of the dry pile batteries that are used to power the device. The dry piles are very early batteries that use alternate discs of silver, zinc, and coated with sulfur that generate low currents of electricity. The Oxford Bell invention consists of 2 brass bells that are each positioned beneath 2 of these types of dry pile batteries that are covered in molten sulfur and look much like candlesticks inside of a glass enclosure. In between the 2 bells is a metal sphere, or bell clapper, that is suspended between 2 brass bells. Each bell connected to a dry pile battery produces a tiny electrostatic charge that repels the tiny bell clapper, sending it quickly back and forth between the 2 bells. It was invented sometime around 1825 by London instrument makers Watkin and Hill. But here's the mind-blowing thing about this invention. It was first displayed in 1840, and the bell has been ringing ever since. That's 182 years to date. Some say that it could have started ringing the minute it was constructed 15 or so years earlier, and some estimates state that the bell has rung over 10 billion times, and it's still ringing today. Aside from this very surprising fact, the bell has some other mystery about it, and that is no one is exactly sure what the dry pile batteries are made of or why the batteries have lasted so long. We know that they're coated in sulfur, but what's inside is a secret. And they weren't expected to last very long. In fact, a year after the bell was set up in the Clarendon Laboratory of Oxford University, Watkins and Hill wrote in a letter that the residual electrical power to keep the bells ringing seldom lasts longer than 3 or 4 years. We're certain if they were still around today, they'd be proud to learn their bell is still ringing. After all, their batteries put our smartphone batteries to shame. Researchers are now waiting for the bell to stop ringing so they can open the batteries and figure out exactly how they were constructed. That is, if the bell ever stops ringing. It's an incredible invention, but is it a perpetual motion machine? You could say that it's another close but no cigar invention. This is because the batteries will eventually die, or the clapper will wear out first. Also, some energy is lost due to the air friction between the clapper and the bell, even if it is very small. Therefore, it's not a perpetual motion machine. We talked a bit about air friction with Newton's cradle, and you can see how air friction will eventually stop the Oxford Bell clapper, causing both to run at less than 100% efficiency. So what about an invention that's in a vacuum or partial vacuum? It turns out an invention like this does exist. This is called the Crookes radiometer, or light mill, and was invented by British chemist and physicist Sir William Crookes. A radiometer is a device that measures the amount of radiation hitting an object. Inside of the partially vacuum-sealed bulb is a set of 4 vanes balanced on a single pole that has free movement. Each vane has a white reflective side and a black side. When the glass bulb is exposed to the light, the vanes begin to rotate. The more light that is shone on the glass bulb, the faster the vanes inside will turn. You would think that light is actually putting pressure on the reflective side and causing them to move. However, the real reason that the vanes in Crookes' radiometer spins is something called thermal transpiration. So what actually happens is when you shine a light on the bulb, the glass heats up and emits invisible infrared radiation, and the black side of the square vanes picks up more radiation than the white side, and thermal transpiration causes the vanes to spin. And for the record, Crookes' radiometer also works in reverse, meaning that if you cool the bulb down by pouring cold water over it or using ice on the glass, the black side of the vanes will emit infrared radiation better than the white side, causing the vanes to spin in the opposite direction. But just like the Beverly clock, Crookes' radiometer is not a closed system and requires external forces for it to operate. Therefore, it's also not a perpetual motion machine. The fact is that a perpetual motion machine may never exist. There'll never be a closed system that can run at 100% or greater efficiency. The thing about perpetual motion machines is that most of the wacky inventions out there completely miss the whole point of trying to create such a device, and that is to generate more energy than is put in. The only thing inventors have tried, and so far failed to do, is to keep their devices running forever. But there is something in nature that does violate the conservation of energy: black holes. Black holes produce more energy than they consume, thereby violating the conservation of energy. So theoretically, the increase in the mass of black holes caused by cosmological coupling could be used to create perpetual motion machines. Let's say that the Large Hadron Collider is used to create a miniature black hole. The created black hole would evaporate quickly, but when it does, the mass would be a little larger than when it was created, generating an additional output of energy. Such a machine could use the expansion of the universe to obtain pure energy output, which would be equivalent to a perpetual motion machine. We might be really close to figuring this out, since just recently, scientists created a lab-grown black hole that began glowing after simulating an event horizon. Until then, we have to marvel at the many attempts and strange inventions used by those who claim they've made a perpetual motion machine. We'd like to know what you think, and if you enjoyed the video, give us a like. It really helps us out. And make sure to stay tuned here by subscribing for more exciting videos to come. Thanks for watching.